Welcome to Land Administration S'mores, where complex land issues meet campfire clarity. My name is Jack McKenna. I'm a geospatial consultant and land administration subject matter expert. We break down land rights, cadastral systems, geospatial tools, human rights, and property law into digestible bites, just like s'mores. From boundary disputes to land grabs, titling systems to tenure security, we're here to inform, ignite debate, and inspire change. Whether you're a professional, an academic, a student, a policymaker, or simply land curious, grab a virtual marshmallow and join the conversation. Our conversation today is UAS measurement assurance, where we seek to acquire accuracy you can trust and decisions you can defend. Measurement assurance in UAS photogrammetry, standards alignment, institutional risk, and implications for authoritative mapping. I am Jack McKenna with Land Data Plus. The agenda with the introduction, the standards context, ISO and ASPRS, technical considerations in direct georeferencing, precision versus accuracy, implications for authoritative mapping and land administration, risk-based considerations, second generation NSDI perspective, discussion and conclusion. Introduction. Modern unmanned aerial system, the UAS platforms, determine exterior orientation using tightly coupled GNSS plus inertial systems. Major benefits are lower costs, faster delivery, wider accessibility. And the emerging challenge, generalized claims that survey accuracy can be achieved without ground control. The central question, should reduced field control be interpreted as eliminating the need for independent verification? UAS with integrated GNSS plus IMU now enables high-precision direct georeferencing. It significantly reduces reliance on traditional ground control points, GCPs. Claims of survey-grade accuracy without GCPs raise important professional questions. The core thesis: technological capability does not replace standards-based verification. Independent validation remains essential for authoritative geospatial products. The key takeaway: precision does not equal accuracy. The standards context: ISO 19157 for data quality, positional accuracy, completeness, logical consistency, lineage, that's the documented history of the data, requires transparent quality reporting. ISO 19130, sensor models and geolocation, rigorous calibration and error characterization, emphasis on traceability and reproducibility. Standards: ASPRS and national practice. ASPRS Positional Accuracy Standards, Edition 2. Accuracy must be empirically tested using independent checkpoints. It cannot be inferred from system specifications alone. National mapping authorities, for example, Swiss Topo, strong emphasis on empirical validation and reference frame integrity. Authoritative data requires rigorous quality assurance. Technical considerations. Advantages of direct georeferencing. Reduced independence on GCPs for bundle adjustment. Residual error sources still present. GNSS biases, multipath atmospheric effects. Lever arm offsets and timing synchronization. GNSS antenna IMU and camera sensor offset distances. Sensor calibration uncertainties. Block geometry and self-calibration deformation. datum transformations, and geoid modeling. Conclusion: independent checkpoints remain critical for detecting systematic biases. Precision versus accuracy, the concept and the definitions. Precision, internal consistency and repeatability. The risk can be high while having bias. Accuracy, closeness to true and reference value, requires independent validation. High precision with systemic offset is possible. Standards demand independent checkpoints of higher accuracy. Implications for authoritative mapping. Critical for land administration, infrastructure planning and regulation. ISO 19152, the Land Administration Domain Model, the LADM. It links people, land and rights. Errors in spatial data can lead to boundary disputes, loss of public trust, legal and financial consequences. Key point: spatial data quality is an institutional issue, not just technical. Risk-based considerations. Adopt a risk-based validation approach. The low risk for visual mapping, preliminary planning, which has a lighter validation. High risk, cadastral boundaries, engineering design, flood modeling, infrastructure, rigorous independent verification. Recommendation: scale the validation effort to the consequences of error. Second generation NSDI. The NSDI Geospatial infrastructure as a digital operating system of governance. Key elements: professional guidance, ASPRS, national authoritative reference systems, international standards, ISO. Direct georeferencing must integrate with validation to maintain interoperability, transparency, and public trust. Discussion. Direct georeferencing delivers major productivity gains. Standards are enabling frameworks, not obstacles. Provide clear guidance on appropriate use and validation requirements. Collaboration between vendors, practitioners, and standards bodies is essential. The goal: innovate responsibly while preserving measurement integrity. Conclusion. Direct georeferencing is a transformative advancement. Foundational principle remains: positional accuracy must be independently verified. Especially important when data supports public policy, infrastructure, and legal rights. Closing reflection. Accuracy is a public trust. You anchor the innovation in the enduring disciplines of measurement science. Again, I've been Jack McKenna with Land Data Plus. Thank you for your time and attention. We're all about good decisions today and better land tomorrow. Thanks for joining us around the campfire.